Everyone, myself Dr. M.V. Sudhakar, working as a professor in Lakredi College of Engineering, Mailaram, in the Department of Electronics and Communication. So, I would like to present basic concepts of satellite communication system. So, what is satellite? A satellite is a smaller object. A satellite is a smaller object which revolve around the earth in a fixed path. So look at here, this red dotted color circle is a orbit. This is the path of satellite around the earth. That means a satellite is moving in this path around the earth. So from the definition of the satellite, a smaller object which is revolving around the bigger object in the space, having the particular path. This path we call it as a orbit. So satellites are two types. So from the basic definition, satellite moving around the bigger one in a fixed orbit. Natural satellite means, in this example, moon move around the earth, we call it as a natural satellite. Example is moon. Similarly, if any man-made satellite that we place in a orbit that also revolve around the earth to monitor the atmospheric conditions or to provide the GPS, this kind of satellite we call it as a artificial satellite. So these are the different types of orbit. Equatorial orbit means a orbit moving along the equatorial plane of the earth, and whereas the polar orbit which is covering the north and south pole of the earth. So other than these two orbits, we call it as a inclined orbits. So based on the height of the orbit, the satellites are further classified into LEO, lower Earth orbit, MEO, medium Earth orbit, GEO, geostationary orbit. The lower Earth orbit, having the height of 160 to 2000 kilometers, used in the satellite imaging as well as internet purpose like Starlink. Similarly, medium Earth orbit having the height of 2000 to less than 36,000. It is used for the GPS applications, and its delay to complete the one rotation is in between 2 to 24 hours. Geostationary orbit having the height of 35,786 kilometers. So it is used for the DTH applications, and it takes around 23 hours 56 minutes to complete the single rotation. So based on the shape of orbit, this is further classified into circular orbit or elliptical orbit. How satellite works? So in satellite communication, we can see uplink, downlink. Uplink means transmission of signal from earth station to the satellite. This path we call it as a uplink, and this is the downlink, a signal transmission from satellite to the earth station. So satellite having the transponder. So satellite receive the uplink signal, it perform amplification and also frequency conversion and send back to the destination. The transmitted signal reaches the satellite via uplink, and satellite transponder performs amplification, frequency conversion, and send back to the other station via downlink. So satellite having the two segment. One is space segment having the satellite. This is the how satellite look like, And this is the earth segment. Earth segment having the three portions: user, terrestrial system and earth station. So user or customer transmits the signal, voice, video, text, and that reaches the earth station via terrestrial system, means land, water, etc. Similarly, this process also applicable to the downlink. Kepler laws are very important to understand how satellite is moving in this space. So further, Kepler laws divided into three types: first law, second law and third law. First law states that when the satellite is moving in the orbit, it is in the shape of ellipse. So depending on the eccentricity, we can see the different sizes of the ellipse. So from the Kepler first law, Earth is at one of the focal point of the ellipse, and this is the red color line shows the satellite moving path. So from the first law, we know that satellite having the elliptical orbit. So according to the Kepler second law, in a equal interval of time, let us consider the 1 hour. In a 1 hour, satellite in the orbit covers the distance s2. In the same hour time, here also in 1 hour time cover the distance s1. But area corresponding to the distance traveled s2 is a2. Area corresponding to the distance traveled s1 is a1. As per the Kepler second law, areas are equal. a1 equal to a2. The definition of the Kepler's third law: orbital time period. Orbital time period means, if this is the Earth, this is the orbit of the satellite. The time taken to complete one orbit is the orbital time period t. This is directly proportional to the semi-major axis. If you see the ellipse, this is the A is the semi-major axis. So from the third law, so square of the period is directly proportional to cube of the semi-major axis. So to find the orbital time period is the time taken to complete the one orbit. So for elliptical orbits, 2 pi by square root of mu a power 3 by 2. Similarly, for circular orbit, this is the formula.